So we are in Module 2. We are in Topic 2, Lesson 3, Dining, Dancing, and Driving. Linear relationships in context. So we are going to be dealing with word problems. So the lunch special at the pizza shop is 2 slices of pizza for $5. So the most important information right here is that we have 2 slices of pizza for $5. Express the cost of the pizza as a unit rate. So unit rate means that we're going to have cost per one slice. So we need to know the cost per one slice. So we have $5, and that's for 2 slices. So now we need to divide that. So I'm going to divide that, and I'm going to get 2.5. Which means it's $2.50 per slice. Now we're going to write an equation for this situation, and we're going to define our variables. So remember that when we're talking about defining our variables, we have to say what the x and what the y are going to stand for. So the x in this instance is going to be the number of slices. Now, how did I decide on that? How did I decide that it was going to be number of slices? Remember when we talked about this, usually this part right here is our independent variable or our x variable, where the first part of this situation, which is the money, that is going to be our dependent variable. So the total cost is going to be our dependent variable, or it's going to be our y value. Okay, so let's go to this next part. Dependent on your point of view. Identify the dependent quantity and the independent quantity in each problem situation. Terrence buys canned vegetables at his local grocery store to donate to the local food pantry. Each can costs 59 cents. Now, when we say that, normally we say I'm not sure why it's going so slow. 59 cents per can. And just like what we just talked about, this part over here is going to be our independent. That was weird. Okay, that is going to be our independent variable, where our dependent is going to be the cost. Because the cost depends on how many cans you are going to buy. So it depends on how many cans you're going to buy as to what the total cost is. So let's look at this. The amount of electricity used by a light changes as you turn the knob on the switch. Now, some of you are like, turn the knob on the switch. Okay, let's pretend that instead of having, we have a knob here, and this is like the off position right here. I guess I should have put off up here. Whatever. If I turn this direction, you may have a little bit of light, and then you get all the way over here, and this will be the max amount that you have. So you use a little bit of light, and then you get a whole bunch of light. Okay? So if this is in the off position, you're not using any electricity. Okay? So the knob in the off position, there's zero electricity. Okay? If the knob is in the max, you're going to be using a lot of electricity. Okay? So the amount of electricity depends on the placement of the knob. So this part over here depends on, so it is dependent on the knob. So this is independent. Okay? So the next one. Stephanie sells Girl Scout cookies to raise money for the local troop. For each box, this right here, guys, that gives you a hint right there. For each box, the troop receives $2. Okay? Isn't this saying they receive $2 per box? So that means the amount of money that the troop receives depends on how many boxes were bought. How would each problem situation change if you switch the independent and the dependent quantities? So let's change it. I'm going to change it to a pink now. Let's go up here and say this. So if I switch these around and I said cans per 59 cents. Well, if I change this for the number of cans per dollar. Okay, how many cans can I buy for $1? Okay, so then I have to think about it. Well, if each can's 59, I can only get one can. So that doesn't really make a lot of sense to do it that way. Sometimes, yeah, you have $10 and you have to figure out how many cans you can get for that. But in a normal situation, they talk about how much it's going to cost when you buy a certain amount of cans. So this next one. So if I was to do this one, it would be electricity per knob setting. Okay. So usually the electric company doesn't say, hey, you only have this amount of electricity, so don't move your knob, or don't put your electricity on high setting. Now, sometimes the state says, or the federal government or whatever say, please limit the amount that you're using, but they don't like shut off your electricity if you use more than that. Now, this one would have been number of boxes per $1. That's what its unit rate would have been. Okay, so a half a box per dollar. Now we could think of this as a fundraiser. If you wanted to get to a certain amount of money, how many boxes do I need to get in order to get to that amount. So that would work. But again, normally you want to know how much it is per box. Okay, so now let's look at this. Choosing an independent and dependent quantities. You can choose different independent and dependent quantities to model the same information, depending on what you want to know. Once you've determined the independent and dependent quantities, you need to just need 2 points to determine the slope or unit rate. So let's look at this information about Josh. Josh took a road trip with his family to visit Yosemite National Park in California. The table shows they went a total of 2,600 miles. The gas cost $200, and they used a total of 80 gallons. So after they arrived, Josh was curious about how many miles per gallon their car got on the trip. So right here, it tells miles per gallon. It's telling you what information we want. So we're going to want miles and we're going to want gallons. So we have to decide which one is which. So again, independent is gallons. So X equals number of gallons. Okay. Y equals the number of miles. Okay. Now, right ordered pairs of 2 points that we can use for the answers to the question. So, if I look at this information that's up above, we're talking, and I'm just going to do this as a shorthand. We're going to put gallons here, and we're going to put miles here. Okay? So when I started this trip out, or when Josh started this trip out, how many gallons of gas had he used? He'd used 0 gallons of gas. Miles, how many miles had he gone? 0 miles. He hadn't gone anywhere. Now, using the information that's up above, how many gallons of gas were used? It says up there 80. How many total miles were gone? 2,600 miles. Okay. Now, determine the rate. So that means I have to find slope. Remember, when we're finding slope, this is the equation. This is the formula. So I'm going to put in my y values. 2,600 minus 0, 80 minus 0. So that's 2,600 over 80. That cancels out. And then I'm going to take my calculator. And I'm going to say 260 divided by 8. And I'm going to get 32.5 miles per gallon. Oops, I misspelled gallon. There we go. 32.5 miles per gallon. How many miles per gallon did their car? Oh, I already answered that. Sorry. Okay, so now let's go. It says the family wants to know about how many gallons of gas on average they use for each mile. Okay, so we're still using the same information on this. It wants to know how many gallons of gas they use per mile. Up here, we wanted miles per gallon. Down here, they went, and it doesn't really say it, they want to know gallons per mile. So all that we've done now is we've now switched it around. So now the independent is the miles and the dependent is the gallons. So we're going to switch around what we did. So now the miles comes first, then the gallons. 0, 0 is where we started off. Miles, we went 2,600 miles on 80 gallons of gasoline. So I'm going to set this up. I'm sorry. There we go. M equals, I subtract 80 minus 0, 2,600 minus 0. So my slope gets me 80 over 2,600. So then I just use my handy dandy calculator. 80 divided by 2,600. And it's approximately 0.031 gallons of gas for 1 mile. Okay. What is the family's average gallons? Oh, I just did this. Round to the nearest hundredth. So 0.03 gallons per mile. Okay. If the family had flown, they would have traveled 2,100 miles and spent $3,250 for tickets alone. Compare the cost per mile for flying and driving. Determine the independent and dependent quantities and the rates for each relationship. So this one's cost per mile. So again, independent is going to be the miles. Dependent is going to be the cost. So we've got miles and we've got cost. So on this one right here, we started off with 0 miles, it cost $0. Then we have 2,100 and we have 3,250. So let's find the unit rate for this one. So M equals, and I take 3,250 minus 0 over 2,100 minus 0. Again, that gives 3,250 over 2,100. So if I put that into the calculator, 3,250 divided by 2,100, I would get approximately 1.54, actually it's, I'm going to do 55. And that's dollars per mile. Okay. Now let's change it to the information from above. Okay. So if I come back up here, it's wanting, this time around, it wants the price and the miles. So it's $200 for 2,600 miles. Okay, so this time, oops, I meant to change that. 2,600 miles and it costs $200. So again, I set this up. Oh, and we started at 0, 0. So that my mind is boggled. Okay. So I get 200 over 2,600. And that's going to come out, sorry, to approximately 200 divided by 2,600. 0.08. 8 cents per mile. Okay, so we did that. So which one is the better one? So driving is cheaper. Driving is cheaper. How much is it cheaper? $1.55 minus 8 cents. Oops. By $1.47 per mile. That's a lot. That's a lot of money. Okay, so let's look at this next one. Determine the slope and y-intercept from the context. So first you're going to identify the independent and dependent quantities, right? Ordered pairs of 2 points. Explain what your ordered pairs mean, and then determine the rate described. Okay, no big deal. Here we go. Bella's Pizza Shop charges $9 for a large pizza, and any toppings ordered cost extra. Bruce ordered a large pizza with 3 toppings. That cost $12.60. Okay, what is the cost per topping? Okay, so this is what it's looking for. Okay, so this right here is going to be my y, or my dependent variable. This is going to be my x. So when we do this, it's going to be toppings and then cost. So if I have 0 toppings, how much would this pizza cost? It would cost automatically $9. If I had 3 toppings, right here it said 3 toppings, it's going to cost $12.60. Now, we need to find out how much it costs per topping. I guess I should have said number of toppings. So we're going to set it up. I need to do slope. I don't know why I wrote that. Okay. So I'm going to take 1260 and I'm subtract 9. I'm going to take 3 and I'm going to subtract 0. When I subtract this, hopefully when you subtract this, you will also get 3.6 on top and 3 on bottom. So when you divide that, that's 1.2. So that is $1.20 per topping. So it costs $1.20 per topping. Oops, I didn't mean for it to do that. Sorry about that. Okay, so this next one, it says after 10 shifts, a maintenance crew paves 1.25 miles of road. After 45 shifts, the crew paves 5.625 miles of road. At what rate is the maintenance crew painting the road in miles per shift? It tells you right here, miles per shift. Again, miles is going to be my y, x is going to be my number of shifts. So, number of shifts, comma, number of miles. So, the first one says the number of shifts is 10, and the miles they went was 1.25. Then the next part says that they went 45, and they did 5.625. So what they want the rate. Rate means that we're finding the slope. So we subtract 5.625 and 1.25 because those are the 2 y values. Because we use 5.625 first, we have to use 45 first on the bottom and then 10. So we are going to subtract and we are going to get, is that right? I think so. 4.375 over 35. We're going to divide, and we're going to get 0.125 what? Miles per shift. Okay, next one. Melanie makes 15 dozen breakfast rolls in 3 hours. After 8 hours, she has baked 40 dozen breakfast rolls. At what rate does Melanie bake breakfast rolls each hour? Okay, so it says, at what rate does she bake breakfast rolls? So, hours is going to be my X. Number of breakfast rolls is going to be my Y. So over here, I have hours and rolls. So at 3 hours, there were 15 dozen. At 8 hours, there were 40 dozen. So again, I set up my slope. Y's are subtracted on top, so 40 minus 15. X's are subtracted on bottom. So that will get me 25 over 5. So 5 dozen per hour. Okay, next one. It says Kathy works after school to finish assembling 82 favors needed for the school dance. When she starts at 3:15 p.m., she counts 67 favors already assembled. She works until 4:30 p.m. to finish the job. So, when she starts, it says that she has 67 favors. She is starting at 67 favors. Okay? How many minutes is it from 3:15 to 4:30? For those of you who don't know, 3:15 to 4:15, that's 60 minutes. And then 4:15 to 4:30 is another 15 minutes. That's a total of 75 minutes. So at 75 minutes, she's now made 82 favors. So how many favors can she assemble per minute? So we're going to set this up. 82 minus 67 and 75 minus 0. So 82 minus 67 would get me 15 over 75. She can do 0.2 favors in 1 minute. How many minutes does it take Kathy to assemble 1 favor? Okay. So, if she can do 0.2 favors in 1 minute, this time it's asking for minutes per favor. This one is switching around. Sorry, I'm trying to look for this. Sorry, this one's needing minutes per favor. Okay, so now we're going to switch these around. We're going to make it 67 favors in 0 minutes, and we're going to do 82 favors and 75 minutes. So I'm just switching this around. So now it's 75 minus 0, and it's 82 minus 67. So now it's 75 over 15. I just want to make sure I got the right thing. So this time it's 5 minutes per one favor. Okay, which is more meaningful for this situation? Well, for this situation, this is actually more meaningful for me because, great, I can do 0.2 favors in 1 minute, but I really want to know how long it takes me to do one favor. Okay, so Eddie rented a moving van to travel across the country. The odometer registered at 34,567 miles after he drove for 4 hours. After 7 hours of driving, the odometer read 34,741 miles. What was Eddie's driving rate for miles per hour? So that means that the hour comes first, the miles come second. So the first one, 4 hours, 34,567. The second one was 7 hours and 34,741. So now I need to find the slope. So I'm going to subtract these numbers. So 34741, 34567, and this is 7 and this is 4. So I'm going to take my calculator and I'm going to plug that in. 34741 minus 34567, and I get 174 over 3. And when I divide that by 3, I get 58 miles per hour. Okay, this next one. Julie uses a gift card to buy iced tea for herself and her friends. Monday, after she and her friend ordered, the balance of Julie's gift card was $14.85. Tuesday, after she had 5 friends ordered, she had a balance of $3.97 on her gift card. Determine the cost for 1 glass of tea. So, as we start off we want to know cost for 1 glass of tea. So, number of glasses and then the cost. So, starting off with 0 glasses, she has $14.85 on her card. Then I lied. 2 people ordered. I apologize. And then she and 5 friends, so that would be 6 people, $3.97. So I'm going to find the cost. So I'm going to take 3.97 minus 14.85. Oops, I don't know why I put that parenthesis there. Over 6 minus 2. So hopefully you can already tell that that is going to come out to a negative number. And hopefully you know why that is going to come out to a negative number. Okay, so negative 10.88 over 4. Divide that by 4. And I get negative $2.72. Why is that? Because each time it costs $2.72 per Sorry, per glass of tea. Helps if I do this correctly. Of tea um, off gift card. Okay. Next, determine the y-intercept using the slope formula. Write the y-intercept in coordinate form and explain what it represents. So it says Kim spent $18 to purchase an all-day ride pass for the amusement park and to play 8 games. After playing a total of 20 games, she realized she spent $24. So here we have cost per game. That's what we're looking for, the cost per game. So game and cost. So when I do this, it's 8 games, and it's $18, 20 games, and it's $24. So I'm going to find my slope. That's always what we do first, find the slope. So 24 minus 18 over 20 minus 8. So when I do that, I'm going to get 6 over 12. So that's 0.5. So that means 50 cents per game. But that's not what it's looking for. It's looking for, we want the y-intercept. So the y-intercept. I'm going to use this point right here and this m right here to plug it into y equals mx plus b. I'm going to replace the y with 18, the m with 0.5, the x with 8, and then b. So half of 8 is 4. I subtract 4 from both sides, I get 14 equals b. So that's the point 0.14. What does that mean? It means it costs $14 to get in without games. Okay, next one says Mitch saved money he received as gifts and put it toward buying a bike. When he added 1 week's allowance to his savings, he added $125. After 4 weeks of saving, his allowance was $161 towards. So money per week. Because each week he's getting money. So at 1 week he was at 125, and at 4 weeks he was at 161. So I subtract those. 161 minus 125 over 4 minus 1. So 161 minus 125 gets me 36 over 3, which gets me $12 per week. But that's not what it's asking for. I'm going to use this point, and it wants the y-intercept, so I'm going to plug it in. So the y value is 125, the m value is 12, the x value is 1 plus b. So 125 equals 12 plus b. I subtract 12 from both sides, I get 113 equals b. So that's the point, 113. What does that mean? That means he saved $113 from gifts. I had to look at what it said about. Okay. A context may or may not provide a rate of change. When a problem situation does not provide the rate of change, you can see whether it is possible to generate two coordinate pairs from the information to determine the rate of change. A book of 20 postage stamps costs $8.80. What is the cost for one postage stamp? Okay, cost for one, I don't know why I always do that. Cost for one stamp. Okay, so that means that we want the number of stamps and then the cost. Well, if I bought 0 stamps, it would cost me $0. If I had 20 stamps, it would cost me $8.80. So my slope, take 880, subtract 0, I take 20, I subtract 0, $8.80 divided by 20. I should do this just in my head, but I want to be correct when I do it. Okay, so that means my slope comes out to 44 cents per stamp. Okay, the next one says ticket sales for a locals concert totaled $101,244 yesterday. After the ticket window closed today, the cashier counted 968 tickets sold with a 2-day total of $143,836. Complete the table. Okay. Ticket sales for local concert total that amount yesterday. After the ticket window closed today, so it wants how many are today? Well, this was yesterday. So at 0 tickets sold for today, we have 101,244. After 968, we have 143,836. Okay, so again, we're going to find our slope. I have 1, 4, 3, 8, 3, 6, 1, 0, 1, 2, 4, 4, 968 minus 0. So again, you put it into your calculator, 43,836 minus 101,244, and I get 42,592 over 968. I divide by 968, and I get $44 per ticket. Oops, there we go. Okay, what was the same? Okay, you still had to find slope on both of them. What was different? One started at 0, 0. This one is proportional. Okay, this one is non-proportional. And yes, one has bigger numbers than the other one.